In this third part of indeterminate forms, we are going to see indeterminate forms of the type 0 multiplied by infinity and infinity multiplied by infinity. In my earlier videos on indeterminate form part 1 and indeterminate forms part 2, we have seen we can use L'Hopital's rule directly. So whichever indeterminate form that we are working on, other than these two forms, we have to transform the remaining forms into either a 0 upon 0 form or infinity upon infinity form, so that we can directly apply L'Hopital's rule. So this is what we are going to study in this third part, indeterminate form 0 multiplied by infinity and infinity multiplied by infinity. Let me make one correction. This is not indeterminate forms 0 multiplied by infinity and infinity multiplied by infinity, but instead it is 0 multiplied by infinity and infinity minus infinity indeterminate forms. This correction is applied for all the problems that are solved. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. The first problem in this series is we have to evaluate limit as x tends to 1, x upon x minus 1 minus 1 upon log x. As x tends to 1, x upon x minus 1 will be infinity and 1 upon log 1 will also be infinity. So this is infinity minus infinity form. We will simplify this first and see what happens. X log x minus x plus 1 upon x minus 1 into log x. You can check this is 0 upon 0 indeterminate form. Now we can apply L'Hopital's rule, by which this limit will be derivative of the numerator x into 1 upon x plus log x minus 1 upon by product rule x minus 1 into 1 upon x plus log x into 1. Cancelling this x, it will be 1, and this 1 cancels with this minus 1. So the limit reduces to log x upon x minus 1 plus x log x. This again is a 0 upon 0 indeterminate form. So we again apply L'Hopital's rule to get the limit as x tends to 1, 1 upon x upon 1 plus x into 1 upon x plus log x. After cancelling this x, we get the limit as 1 upon 1 upon 1 plus 1 plus log 1, which is 1 upon 2. Next, evaluate limit as x tends to a log 2 minus x upon a into cot x minus a. This limit is of the form 0 into infinity as x tends to a. We write this limit as log 2 minus x upon a upon tan x minus a, so that it becomes 0 upon 0 indeterminate form. Now we can apply L'Hopital's rule. So this limit becomes derivative of numerator 1 upon 2 minus x upon a into minus 1 upon a upon sec square x minus a. This will be limit a upon 2a minus x into minus 1 upon a upon sec square x minus a. After cancelling this a and taking limit, this will be minus 1 upon 2a minus a upon sec square a minus a, which will be minus 1 upon a. Next we will evaluate limit as x tends to a sin inverse square root a minus x upon a plus x into cosec square root a square minus x square. This obviously is 0 into infinity indeterminate form. So we write this as limit sine inverse square root a minus x upon a plus x upon sine of a square minus x square, so that the limit reduces to 0 upon 0 as x tends to a. Since there are sine functions in the numerator and denominator, we will write two separate limits for numerator and denominator. So for numerator, we write limit as x tends to a sine inverse square root a minus x upon a plus x upon, we write the same angle in the denominator, square root a minus x upon a plus x, and we will cancel this by writing into a minus x upon a plus x multiplied by, for the denominator it will be limit as x tends to a of, the denominator is sine square root of a square minus x square. We write the same angle square root a square minus x square in the numerator, and we will cancel this by multiplying it by 1 upon square root a square minus x square. So we have done these adjustments which are correct. Now we will take the limit, which will be, for this part it is 1 multiplied by square root of a minus x upon square root of a plus x. Pardon me, this should be x instead of 1 multiplied by, this second limit for this part will be 1 multiplied by, we write this part in terms of two factors, square root a minus x into square root of a plus x. Now this square root a minus x gets cancelled, and what we get is 1 upon product of square root of a plus x and square root of a plus x will be a plus x, and the limit for this function as x tends to a will be 1 upon a plus a, that is 1 upon 2a, and this is the value of the limit. Viewers, if you like this video, please click the like button, share this video with your friends and classmates, subscribe to this channel, post your constructive comments to make the videos better. See you in the next video. Until then, keep watching Number Collage. Thank you.